A ratio is a comparison of two numbers. For example, if you were looking at a population of students and there was a majority of boys, you could say there is 2 boys for every 1 girl. Ratios can be expressed in different formats. There's 3 main formats that they are shown in. It could be A to B. You could use A colon, like this, A to B, or as a fraction, A over B. This word right here, extended ratios, can be used to compare 3 or more quantities. And what that might look like is A to B to C with 3 numbers there. Okay, so let's look at this in an actual math problem. It says, in 2007, the Boston Red Sox baseball team won 96 games out of 162 games played. Write a ratio for the number of games won to the total number of games played. This statement right here is really important because it shows you the order of the numbers. It wants number of games won first to the total number of games played. So 96 games were won, and the total games was 162. There's your ratio, but it does need to be in simplest form. So the way we simplify it is the same way you would simplify a fraction. You would divide by a common factor. I noticed that both of them are even numbers, so I'm going to start by just dividing both of them by 2. 96 divided by 2 is 48, and 162 divided by 2 is 81. That may be in simplest form, it may not be. I'm looking again for a common factor I can divide both of those by. It's not 2, maybe 3, and they are both divisible by 3. 48 divided by 3 is 16, and 81 divided by 3 is 27. I would check to make sure I can't simplify that any further, and there are no common factors between 16 and 27, so at that point, you're done. So that's the correct answer. It could also be written as 16 to 27, or 16 to 27. Not it. Okay, so the next example, it says the ratio of measures of the angles in triangle JHK is 2 to 3 to 4. Find the measures of the angles. Well, it shows the picture there, which is nice with the 2 to 3 to 4 ratio. We know that the 3 angles add to 180, so we can set it up like that. 2x plus 3x plus 4x equals 180, and we can solve for x. Then simplify and solve. You get x equals 20. It asks to find the measures of the angles. So once we have x, we can plug that in to find the measure. Here, there's a typo here, it's angle measure. So, for example, for 2x, 2 times 20 is 40. Then 3x, 3 times 20 is 60. And 4x, 4 times 20 is 80. And that's the degrees of the angles. Okay, so proportion. Ratios are used in proportions, or proportion is actually formed by 2 ratios. You can tell if they are equivalent by changing them into decimals and comparing, or cross-multiplying and comparing. Means and extremes, we're going to cross this out. I don't want to confuse you. So we're going to simplify it just by crossing that out. Okay, next. Means and extremes, properties of proportion. Again, I'm going to cross this out. Not that it's not important, but I don't want to give you too much at once. Okay, so here we have some examples. It says, use cross products to determine whether each pair of ratios are equivalent ratios. You may have learned this as the butterfly method in elementary school, where you compare fractions and determine if they're equal. In this case, these are ratios, which are just like fractions. They work similarly. 5 times 9, we get 45. I'm going to make a little note up there. And 4 times 11 is 44. If this came out to the same number, these would be equivalent. However, they did not. So no, these aren't equivalent ratios. B is, we're doing the same thing. 2 times 21 is 42. And 3 times 14 is 42. We get the same number. So yes, these are equivalent fractions or ratios, whatever it's asking. C. Now we have decimals. 0.25 times 2 would be 0.5 or 0.50. And then 0.6 times 1.25, if you plug that into a calculator, it comes out to 0.75. So, these aren't equal, so no, it's not an equivalent proportion. And D. Last one, 2 times 20 is 40, and 2.5 times 16 is also 40, so yes, these ratios are equivalent. Okay, example 3, now we're going to use the same concept to solve for variables. So in example A, once it stop shaking, we're going to use cross multiplication. So we're going to do n times 8 is 8n. 12 times 3 is 36, and we set these equal. And then solve for n, divide both sides by 8, we get n equals 4.5. The next one, same process. 6 times y is 6y. Put that equal to 18.2 times 9. When you plug that in the calculator, it comes out to 163.8. Divide both sides by 6. Y equals 27.3. And C. Here's where it gets a little bit tricky if you don't know exactly what they're looking for. There's also some of these on Khan Academy this week. What we're going to do is same thing, cross multiply. 4 times x plus 4 would be written like this. 4 times x plus 4 with parentheses equal to 3 times 12 is 36. Then we'll distribute the 4 to both of those terms by multiplying. So 4 times x is 4x, 4 times 4 is 16. And then D. Same thing. We're going to do 4x minus 5 times 2. So it looked like this. 2 times 4x minus 5 equals 3 times negative 26. distribute the 2. 2 times 4x is 8x. 2 times 5, so minus 10 equals 3 times negative 26. Oh, I should have written the actual number. 3 times negative 26 is negative 78. Then to solve, add 10 to both sides. And divide by 8. X equals negative 8.5. Okay, so now we're going to look at the word problems where we apply it to actual real-life situations. We're going to cross out this one here and just jump down to B and C. So for B, Monique randomly surveyed 30 students from her class and found that 18 had a dog or cat. If there are 180 students in Monique's school, predict the total number of students with a dog or cat. So we have a smaller sample of 30 students, so 18 out of the 30, so total students. 18 have, we'll just call it a pet. Then we're going to set that equal to, the total for the school is 187 students, and we're trying to figure out how many of those have a dog or cat. So when I set this up, I needed to make sure that the pets are both on the top and the totals are both on the bottom, so that way it'll solve correctly. And then from here, just use cross multiplication. So 30 times x is 30x, and 18 times 870 comes out to 15,660. And we get 522. So it's predicted that 522 of the students would have a dog or cat. And the last one. In an experiment, students netted butterflies, recorded the number with tags on their wings, and released them. The students netted 48 butterflies, and 3 of them had tagged wings. So that's a smaller sample size. 3 were tagged out of 48 butterflies. Predict the number of butterflies that would have tagged wings out of 100. So we're going to set that equal to the larger sample of 100, and we're trying to predict how many have tagged wings. And from here, you can use cross multiplication. You get 6.25. It says, so you would expect about blank tagged butterflies. I'll say about 6. Just round it to 6. And that's it. So from here, you just have homework 7-1 on Schoology. And then I put this as a reminder or like a goal of yours to complete 2 Khan Academy assignments today, just so you're on track for the week. I know you worked on some yesterday, but just do 2 more today. That way you're on track for the end of the week. And you can get up and get your laptops.